and pay for most of it now. This also ties up money that you could be spending on other things, and it's very difficult to forecast accurately over such a long periods of time. Low ongoing costs. Since we invest and operate at such a high scale, we pay less per unit than most anybody else in the IT industry. We run our business on high volume, low margin basis, which is also quite unique. The combination of high scale and low margins allows us to put significant savings to pass it on to our customers. A proof of that is 45 price reductions we have announced over the last few years. Flexible capacity with AWS elasticity, you no longer need to forecast demand and buy upfront. You get the ability to scale to meet the needs for your spiky workloads, and then allows you to give the capacity back when the spike is over, like peak holiday seasons and whatnot. Speed and agility. With the traditional infrastructure, it can take weeks to get a server procured, delivered, configured, and up and running. With AWS Cloud, you can provision resources as you need them. You can deploy hundreds or even thousands of servers within minutes and run your workloads there. Applications, not operations, is the key. AWS lets you shift resources away from data center investments and operations and allows them to move to innovate, work on new projects that you plan to work on. Specifically, you can have your scarce IT resources and engineering resources focus on projects that grow your business instead of having to have them focus on the IT infrastructure or other non-value work. You can also easily deploy your application in any or all AWS regions, which are basically the data centers located across the globe. So here is our global footprint. This means you can also provide a lower latency and better experience for your customers at minimal cost, depending on where your customers are located across the globe. Our footprint is expanding continuously as we increase the capacity, redundancy, and add locations to meet the needs of our customers across the world. There are 11 regions. Within a region, we have multiple availability zones that allows you to set up high availability workloads. And we also have multiple edge locations across the globe. I just noticed that there is a star missing on the map for our new Frankfurt region. It's another challenge for me to keep this slide up to date at the pace at which we are growing around the globe. Like I said earlier, we announced a ton of price reductions over the last few years, roughly around 45 times since our inception in 2006. This year, we announced huge price drops for Amazon Elasticache, Amazon S3 by almost 51%, and Amazon Route 53 lowers the prices for both the standard queries and also latency-based queries. So diving deep into a little bit on the computes and scaling and load balancing services, our Amazon Elastic Compute Cloud EC2 is a web service that provides resizable capacity in the cloud. It is designed to make web scale computing easier for developers. EC2 enables you to increase and decrease capacity within minutes, not hours, not days. This is within minutes. You can commission, one or hundreds of server instances simultaneously by setting up an auto scale configuration. This is all controlled, obviously, through either web services APIs that we provide, or your application can call those APIs directly. We have a management console that you can work with. Lots of tools available for you to interface with the Amazon feature set. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It also enables you to achieve even greater fault tolerance in your applications by seamlessly providing the load balancing capacity needed in response to the incoming traffic. So as your traffic scales, we scale and provide the services for you. Looking at our networking services, our virtual private cloud, VPC, lets you provision a logically isolated section of Amazon Web Services Cloud where you can launch AWS resources in a virtual network that you define. You have Complete control over your virtual networking environment, including the selection of your own IP address range, creation of subnets, configuration of route tables, network gateways, configuring security, and so on. Direct Connect makes it easy to establish a dedicated network connection from your on-premises environments or data centers to AWS. Using Direct Connect, it's a private connectivity between your data center and AWS, which in many cases can reduce your network costs, increase the bandwidth throughput, and provide more consistent network experience than the internet-based connections that you may choose to provision. Route 53 is a highly available and scalable domain DNS system. It is designed to give developers and businesses an extremely reliable and cost-effective way to to route end users to internet applications. Let's touch base a little bit on the storage services. Our Elastic Block Store provides block-level storage volumes for use with Amazon instances, and EBS volumes are network attached and persistent independently from the life of an instance. S3 is a storage for the internet. It is designed to make web scale computing easier for developers. Amazon S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any amount of time from anywhere on the web. So if you're looking at backup solutions or storing data out there on the internet, S3 provides you the HTTP interface. You could simply download data from it anywhere across any of your data centers or workspaces. Amazon Glacier is an extremely low-cost storage service that provides secure and durable storage for data archiving and backup. And Storage Gateway is a service connecting an on-premises software appliance with a cloud-based storage to provide seamless and secure integration between an organization's on-premises IT environment and AWS's storage infrastructure. This service enables you to securely store data to the AWS cloud for scalable and cost-effective storage. So this is one of those on-premises appliances that you could set up within your environment in an Hyper-V or a VMware environment, and it exposes the interfaces that are required to ship the data from your on-premises into AWS storage services like S3. Touching a little bit on the architecting for performance, like I said earlier, we have Amazon Elastic Block Store that provides block level storage volumes for use with Amazon EC2 instances. And some of the instance types, Amazon EC2 instance types, allocate a dedicated bandwidth to its attached EBS, standard, and provision IOPS volumes. So as a best practice, we recommend using EC2 EBS optimized instances for database type workloads or workloads that require large data set store that needs to be provisioned on an instance. They deliver a dedicated throughput with options between 500 to 2000 megabits per second, depending on the instance type that is used. Provisioned IOPS volumes can also achieve single-digit millisecond latencies and are designed to deliver within 10% of the provisioned IOPS performance 99.9% of the time, which is the SLA. Recently, last week at reInvent, we announced Amazon EC2 C4 instance types. These instances are aimed at customers with applications that require high levels of performance. These instances are great match for the SSD-backed Elastic Block Storage that we introduced earlier this year. And also EBS optimization feature that we just talked about in the previous slide is also enabled by default for all C4 instance sizes. So these are some of the great options for you to set up high storage workloads within the AWS environment. Another announcement that we made last week is the availability of the 16 terabyte volumes. Again, this is also great for large databases or any storage intensive workloads that require high throughput, high IOPS, and the large volumes that need to be attached to the EC2 instances. Previously, the limitation on the Elastic Block Store was 1 terabyte. So now you could start using 16 terabyte EBS volumes. We also have a quick start program that allows you to readily deploy an environment. For example, so the workloads like Windows Server, failover clustering environments, remote desktop gateway environments, Active Directory domain services environments. All these are scripted in a CloudFormation template. It's a simple JSON formatter template that allows you to script the environment for you, and then you can take the CloudFormation template and run within your AWS account to set up the entire environment. You can also download these templates and customize them based on your requirements. For example, if you already have Active Directory services running, you could take the SQL Server template, remove the Active Directory pieces from it, and then just customize for it to launch just the SQL Server, for example. So I highly encourage you to take a look at this, the Quick Start program. To download and use any of the templates that we have made them available for you. So with that, I'd like to introduce Tony. He's a Director of Field Engineering at SIOS. Tony will provide us some information about deploying high availability workloads using their software on the AWS environment.
Excellent. Thanks, Vikram, and thank you all for your attendance today. So as he mentioned, my name is Tony Tamarchio. I'm with the field engineering team here at SIOS. I've been with the company now for just over 4 years. And today I'm going to be focusing on ways and show you how you can achieve native failover clustering, so using Windows Server failover cluster up in AWS. So most commonly we see people deploying SQL clusters, but really this could be used for any workload that you're interested in maintaining the high availability for. So it could be SQL servers, could be file servers, could be custom applications, or really anything else. Any clusterable workload can be protected. So we'll get into the details on how that all works. I'll even show you a live demonstration. I'll also take you through a case study and show you one of our customers and how they've deployed our solution to ensure maximum uptime for their mission critical applications. But before I jump into all these details, first a quick background on SIOS. So SIOS, we've been around for well over a decade. We were founded back in 1999, formerly known as Steel Technologies. We're based out here in California, but we have a global presence protecting thousands and thousands of servers and applications around the globe in lots of different types of configurations. Physical servers, virtual servers, or now we are very commonly seeing deployments up in the cloud. The products that we offer, we have our SIOS Protection Suite as well as our DataKeeper Cluster Edition product. And our DataKeeper Cluster Edition product is what we're going to be primarily focusing on here today. It's a replication technology that integrates with the native failover clustering features that are part of the Windows Server operating system. And we make it very easy to deploy native clusters up in AWS. So if we step forward here, at SIOS, we're all about availability, not just of applications, but also for your data, your mission-critical data. So we cover a wide range of configurations, physical servers, virtual servers, certainly cloud environments. And as people move their applications up to the cloud, we see a wide range of configurations as well, whether that's deploying everything up in the cloud, or maybe a hybrid configuration where they're looking for an easy way for disaster recovery and using the cloud for DR, for example, failing over from your data center up into the cloud in the event of a data center loss, as an example. Or perhaps your entire workload is up in the cloud and you want to be able to ensure maximum application availability, maximum uptime for the workload that's deployed entirely up in the cloud environment. So we've got all of these different bases covered here through technologies. And the way that traditionally applications have been made highly available is through the use of a cluster. And the diagram that we have here on the screen is what most people would envision. And when I say the word cluster, historically this has been 2 or more physical servers, all connected to some type of shared storage. It might be a fiber channel or an iSCSI type SAN. And that works great in on-premise solutions. But in this type of an architecture, technically your shared storage is a potential single point of failure. If you have an issue with the shared storage, it can take out your entire cluster. Additionally, up in cloud environments, shared storage generally isn't available. So a traditional cluster is either very difficult or impractical or perhaps impossible to deploy out of the box without additional technology to enable high availability. And that's exactly where SIOS comes in and where we come into play here. So where SIOS plays is we enable the deployment of high availability failover clusters in cloud environments. The native Windows Server failover cluster technology, as I just mentioned, requires that all servers in the cluster are connected to shared storage, right? And the different instances up in AWS, they have, for example, their uniquely assigned EBS volumes that are not shared between instances. So you don't have shared storage. So the way that we solve this problem is through our replication technology. Again, the product that we're talking about here is called DataKeeper Cluster Edition. And we enable what we call SANless clustering. I'll also refer to this as a shared nothing clustering architecture where you're not sharing storage between the different nodes. And in this case, our replication technology would handle the real-time replication of your data so that the different nodes in the cluster are kept in sync. So should one instance or the application, or there's some type of an issue on your currently active server, it'll fail over to another node in the cluster. And because we've been replicating your data in real time, block for block, all of your data is safely stored on another instance up there, and you can bring it on back online automatically with zero data loss. So we allow local storage to look, feel, and act as if it was shared between systems. So we've achieved that through integrating our technology with the native Windows Server failover clustering features that are part of Windows Server, or the Windows Server operating system. So this is a simple diagram of what a DataKeeper enabled cluster looks like. So here, this could be 2 nodes, could be certainly more than 2 nodes. We do support multi-target replication. So here I have a simple example of a 2-node SQL cluster. These would be 2 different Amazon instances. Ideally, they'd be in different availability zones. And we perform real-time block-level data replication between the systems. So for example, let's say all of my SQL data lives in my D drive or E drive or F drive, whatever drive letter that might be. We're essentially doing a software RAID 1 mirror across the network. So your volumes are mirrored block for block. And when you have an issue with your cluster, and let's say the primary server fails, SQL fails over to the other node, it's brought back online, DataKeeper automatically starts replicating your data in the opposite direction. So when the failed node comes back online, the data is synchronized back to get that node caught back up to speed. But you've maximized your uptime because a server failure or a networking issue or an issue with the application or perhaps the configuration hasn't taken down the entire application. So the whole idea with the cluster is to fail it over, bring it back online as quickly as possible. And now with DataKeeper, we enable that functionality in environments that don't have shared storage. DataKeeper does support both synchronous and asynchronous replication. So typically within a region, you have high-speed, low-latency networking between your instances. Typically, synchronous replication would be used there. Synchronous replication is always preferred because it's zero data loss. It's a double commit, so you know that when your data is written, it's safely made it to both the source and target sides of the mirror. Now, the opposite would be asynchronous. So if you're doing a geo cluster and you're going across different regions or from your data center up into the cloud, going across the public internet where there very well might be latency, that's typically where asynchronous replication would be used. So you can select the mode of replication that makes the most sense based on your business requirements and your recovery point objectives here. So this is a simple example of what a cluster looks like when DataKeeper is involved to eliminate the shared storage requirement and to provide real-time block-level replication. So typically, customers are clustering SQL Server. That's the #1 workload that we see. We do a lot of file servers, custom applications as well. But the benefit of DataKeeper's replication engine here is because we are a real-time block-level replication engine. It's a very efficient, very low overhead replication technology. We're talking that the driver uses 2 to 4 megs of memory. There's no noticeable CPU utilization unless you turn on things like compression. So it's suitable for both single site as well as multi-site configurations. It's also very easy to set up. I'll show you in the demonstration in a little while, but we have a very intuitive MMC interface to set up a mirror, to create a new mirror and have that registered as part of the cluster. It's a 3-step wizard. And from there, if you've ever set up a failover cluster on premise, you already know 95% or more of what it takes to do all of this. We're simply the added ingredient, enabling real-time replication and augmenting the already robust capabilities of failover clustering, now enabling you to achieve this without the shared storage requirements. So just so you know, SIOS, we are a Microsoft Gold certified partner. DataKeeper is logo certified for Windows Server 2008 and everything newer, so this is fully supported. So with any failover cluster, your cluster needs to pass what Microsoft calls cluster validation. So when you form your cluster, it passes cluster validation. It will still pass cluster validation when DataKeeper is involved. So as long as your cluster passes validation, as far as Microsoft is concerned, you have a fully supported configuration here. So that's very important that you're not jeopardizing or invalidating your support by going to a shared nothing or a SANless cluster configuration like this. So very powerful technology here. So the way that this is typically deployed up in AWS is you would set up your VPC, and for maximum availability, you're going to have multiple availability zones. So typically, I'll have, let's say a simple 2-node cluster here. I'll have my 2 different EC2 instances in different availability zones, so that an issue with an availability zone doesn't take out all of your cluster nodes. And with failover clustering, it has, if you're not familiar, there's the concept of quorum. So on premise, you would typically use a quorum disk on your SAN as an arbitrator, if you will. Up in the cloud, where there is no shared storage, that's where Microsoft gives you the option to implement a file share witness. So this is the most common configuration where you have the different cluster nodes in different availability zones, and then ideally you would have your file share witness in a 3rd availability zone. That way, if you, for example, lost your instance 1, if that went down, you still have a quorum because you would have 2 out of 3 votes. You still have your instance 2, you have your file share witness, that's a majority, and auto failover takes place. So if I advance the slides here, if failover does take place, again, SQL Server or your file share or whatever application you're protecting within the cluster fails over to the other node, it'll be brought back online on the other instance in your cluster, and it will automatically have DataKeeper reverse the mirror, so the source and target roles will switch. The great thing about DataKeeper is you don't have to manually manage your mirrors. It's all controlled through failover clustering. Again, we're basically just taking the independent storage attached to each instance, and we're making the cluster think that it's shared storage through our replication technology as well as through our integration with failover clustering. We've done that by creating what Microsoft calls a third-party storage class resource to the cluster. When I get to the demonstration, I'll show you exactly how this works, how we set this up, and how you can fail over from one node to another when there's no shared storage involved. So this is the typical architecture when you're deploying your cluster and your application entirely up in AWS. Now, we also do have folks who want to do kind of a hybrid config where they have an application that it's running on premise in their data center. Perhaps it's a standalone application, or perhaps they might already have a cluster. And now you want to extend that protection and use the cloud, for example, for disaster recovery or for warm failover. So there's lots of different options to achieve this as well. The top diagram is what I refer to as a 2x1 cluster. So this would be a common scenario where you perhaps already have a SQL cluster or a file server cluster, some type of traditional shared storage cluster on premise. These could be physical servers, these could be VMs, it's up to you. And you want to extend that, perhaps add a 3rd node to your cluster. That 3rd node could reside up in AWS. And we can replicate the shared storage between the first two nodes up to the independent storage on the third system up in the cloud. So you get this cascading failover effect where you can fail over locally between your local systems, and then you can also fail over remotely in the case of a disaster. So, a multi-site cluster, also known as a geo cluster, it's really the best of both worlds. It's both high availability as well as disaster recovery in a single configuration. So that's one very common way to achieve, a hybrid deployment between on-premise and the cloud. If you don't want or you don't have a SAN, perhaps you're looking to avoid the cost and complexity that SANs represent, or also the potential single point of failure that it represents in your clustering architecture. The bottom diagram would be a multi-node configuration where there's no shared storage whatsoever. So this is what I call a 1 by 1 by 1 cluster. The number that I'm saying really represents the number of nodes that are connected to a given disk. So up above we've got a 2 by 1 where two nodes are connected to the same shared disk, and then the one node is connected to its own storage. Down at the bottom, a 1 by 1 by 1 cluster with basically 3 servers, each with local storage or independent storage. And DataKeeper certainly supports multi-target replication. So if I look at these servers 1, 2, and 3 at the bottom, when server 1, for example, is the active node in my cluster and it's running my SQL instance, it's replicating to both server 2 and server 3 in parallel. And I mentioned previously that we support both synchronous and asynchronous replication. So you perhaps would set up synchronous replication locally between node 1 and 2, and then replicate asynchronously up to your third node, which is going up to the cloud across the internet as an example. So lots of flexible configuration options. It really comes down to understanding your recovery time and recovery point objectives. And let me just clarify what I mean by those if you're not familiar. So recovery time objective really is how much downtime can your business sustain? How much downtime are you okay with? Are you talking minutes or hours or days? These days, customers are generally, looking at, less than an hour, generally down to minutes of downtime, if not less. Now, recovery point objective refers to how much data loss can you deal with. And for many customers that we support, they're running mission critical applications and databases, and they can't lose a single transaction, as an example. So that's where synchronous replication plays a key role, because with synchronous replication there would be zero data loss because it's a double commit. The data isn't considered completely written until it's made it to both source and target sides of the mirror. So again, lots of flexible deployment options, whether that's a cluster where all nodes reside in the cloud, whether it's a hybrid config where you have some nodes on-premise, some nodes in the cloud, you can mix and match. So DataKeeper, we're purely a software solution, so we're really server and storage agnostic here. As long as the storage is presented as a block device, so an EBS volume works perfectly for that, or an SSD or a traditional spinning hard drive. Basically, as long as your storage is attached to the Windows server and it's given a drive letter, then you can use that to replicate between your nodes with DataKeeper and use that as a SANless cluster configuration. So some of the key benefits that SIOS brings to the table here is, we're enabling high availability for your mission critical applications in environments where you either don't want to deal with the SAN or shared storage just isn't an option. I've been focusing mostly and been discussing mostly about our Windows technology, but just so you know, if you are running Linux workloads, we do also have solutions, high availability and data replication solutions for Linux as well. So we've got you covered for both Windows and Linux environments. Again, one of the key differentiators with our replication engine is that it's a very fast, efficient block-level replication technology, as opposed to other ways of replicating your data. For example, there's file-based replication technologies out there. We'll talk about technologies that are part of SQL Server itself and database-level replication. Those types of replication generally have a lot more overhead and have a significant performance hit on the performance of your application. So DataKeeper, as we sit underneath the file system doing block level replication, first of all, we can protect any data type. It could be database files, could be PDF files, could be, custom application data. Really, whatever data you put into a volume, we will protect it. We will replicate it block for block and ensure that your data is synchronized and protected between the different nodes in your configuration. Also, this lowers your total cost of ownership because certainly there are key benefits of deploying your applications up in the AWS cloud, as Vikram mentioned. But this also eliminates a lot of the cost and complexity that that come associated with SAN infrastructure. Not just the SAN itself, but the the fiber channel switches and SAN administration and all the additional costs and complexities that come along with it. Not to mention that, again, technically shared storage in your cluster can be a single point of failure, and an issue with your storage can take out your entire cluster. So by moving to a SANless or a shared nothing configuration, you actually can achieve a step higher in the availability chain because you're eliminating storage as a failure point in your cluster. Now, very commonly I get asked, how does this differ from SQL Server availability groups? So with SQL Server 2012 and with 2014, there's a feature called availability groups. And the first thing that I'll mention with this feature is that it's only available with the Enterprise Edition of SQL Server, which is significantly more expensive than Standard Edition. So if you're looking to save money on SQL licensing, you don't want to make the jump to Enterprise Edition, but it still is a mission critical application and you still do want to achieve a high availability, then deploying a SANless cluster with SIOS can be a very simple and cost-effective method to do that. So again, so the first key difference is that availability groups is only available in Enterprise Edition, but DataKeeper will work with any edition of SQL, really any application to that effect. There are also compatibility differences here. With DataKeeper, because our integration point is with failover clustering itself, when you're protecting a SQL Server, you get full instance level protection, just like you would in an on-premise, traditional shared storage cluster. So the entire SQL instance fails over between the different nodes. With availability groups, it's essentially just database level replication. It'll replicate your user-defined databases. So things like your system databases, your master database, your SQL logons, your SQL agent jobs. With availability groups, that doesn't get replicated and protected. So you're essentially managing two separate SQL servers, and you have to make sure that whatever change you make on one, you make on the other. So you can fairly easily get things out of sync. Also, availability groups isn't compatible with distributed transactions. So if, for example, like Link, or there are other applications out there that leverage distributed transactions, or if you're clustering MSDTC today, a failover cluster instance with DataKeeper or SANless cluster with DataKeeper will be completely compatible with that. You're going to have issues trying to deploy availability groups if your application leverages distributed transactions. Also, again, oftentimes, mission critical data that is associated with your application might live outside the database. So again, an availability group type technology is only going to replicate certain databases. But if you had, flat files or PDF files or something that sits in the file system, that wouldn't be protected, but it will be protected with a SANless cluster with SIOS here. So a lot of key differences, both from a cost perspective, because you can do this with the lower cost standard edition, compatibility differences, protection differences. Also, performance is a big difference as well. So DataKeeper, because of our block level replication engine, we are a much more efficient replication engine, and when you're talking synchronous replication, we're going to have a lot less overhead on the system, especially when you start talking higher end systems. If you go to provisioned IOPS and with SSDs and things like that, there's going to be a significant noticeable difference where availability groups will have much higher level of overhead than a SIOS SANless cluster here using DataKeeper replication technology. So I just wanted to bring that up because that's probably one of the most common questions that I see out there as well. SQL 2012 and 2014 have this feature built in. How is this better? How is this different? So I hope that sheds some light here on that topic here. So with that, I'm going to switch gears. I'm going to give you a quick demonstration and show you what a SANless cluster looks like, a DataKeeper powered cluster looks like, how easy it is to set up and fail over, and then we'll switch gears and we'll come back and we'll go through a customer case study. So I'm going to go ahead and share my screen. And in just a moment, you should be seeing my desktop here. And I have a Windows Server failover cluster configured. The server is called SIOS WSFC. It's a two-node cluster. If I look at the nodes, my servers are called SIOS 1 and SIOS 2. And I actually have a couple of different cluster roles. So I've got a couple of different clustered resources here. I have a SQL server, and I also have a file server. So just to show you the flexibility, again, that this really can be used for any service or application that you want to cluster. And for anybody who's set up a failover cluster in the past, this is going to look very familiar. You know, the way that you manage your cluster, the way you fail resources between cluster nodes, that does not change from the traditional way of doing this. Really what DataKeeper is doing is our replication engine is abstracting the storage layer below, and we're making local storage look like shared storage to the cluster. And then of course under the covers, we're also synchronizing your volumes here. So if I take a look here at my highly available SQL instance here, it's currently running on SIOS 1. And the difference from a traditional SAN-based cluster is in this storage section right here. So here I've got this DataKeeper volume S resource, which looks and feels and acts like shared storage. In reality, you know, this would be an EBS volume attached to with a different node. So each node would have their own EBS volume. I give it the same drive letter, same size. DataKeeper is mirroring that at the disk level, and we present that to the cluster as a cluster disk. So if I look at the storage, the disk section of my cluster, I've actually got a number of different DataKeeper resources already in my cluster. So these are two instances. There's no shared storage whatsoever, yet I'm still able to deploy, you know, an out-of-the-box failover cluster and achieve all the protection benefits that failover clustering provides here. So if I want to get DataKeeper resources into the cluster, it's very easy to do so. So let me switch over to the DataKeeper user interface here. And what I'm looking at right now is our overview screen. So here I can see my servers, so SIOS 1 and SIOS 2. We've already seen that I have some of the drive letters already replicated. I have some other drive letters here on the server that aren't yet mirrored, and we'll set that up in our demonstration here today and show how that automatically gets registered. So what I'm going to do now is create a new mirror. I've got this R volume here. We'll create a new mirror for that. That will be automatically registered as a cluster disk at the end of the mirror creation process. And then I can even add it as a cluster disk to my highly available SQL server if I want. So when I do that, I'm going to simply create a job and just give it a name called R drive. And here it's a simple three-step wizard. Step 1, I pick my source. Step 2, I pick my target. And step 3, I pick my mirror options. So here I've got my source server, SIOS 1. If you have multiple network interfaces, you can select which network you want to specifically use for replication. It's always a best practice to separate your replication traffic from your user and your application traffic. And then I've selected the volume that I want to replicate, which is R. Step 2, click Next. It's pre-populated this for me. It selected the other server, the same drive letter, and so on. Don't need to change anything here. And finally, I select my mirror options. So here I can decide, do I want synchronous, do I want asynchronous? So both of these cluster nodes are in the same region. So I'm going to go with asynchronous replication. If I was doing this, you know, from one side of the globe to the other, I would likely go with async, and in that case, I could, you know, enable compression to try to reduce the amount of data that goes between my systems. And click Done. So that's it. So it's creating this brand new mirror. It's going to replicate the contents of my R volume from SIOS 1 over to SIOS 2. And once this is completed, and it just popped up a message on my screen asking if I'd like to register this new mirror as a cluster disk. So I'm going to say yes. If I look at this job before I go back into failover clustering, I can see specifics about this job. I can see the source, who's the target, what drive letter is being replicated, the IP endpoints, and the mirror state as well. Also, there's information down at the bottom about the size and the mirror mode and things like that. Now if I go back in the failover cluster manager and look at the storage, I've got this brand new DataKeeper volume R resource sitting right there in the available storage pool, and now I can use that as part of an existing or a new clustered role here. So now let me show you a failover. So I've got these two cluster nodes. There's no shared storage whatsoever. I want to fail over my SQL server from one node to another. Again, the way that you do that doesn't change from a traditional cluster. You just say, okay, we're going to move the SQL server. We're going to move it over to SIOS 2 and click OK. And just like you would expect, it's failing everything over. And as part of that process, it's also switching over the DataKeeper volume. So it's going to start telling DataKeeper to replicate data in the opposite direction. So previously, replication was taking place from SIOS 1 to SIOS 2. Now it's switched. Data is replicating from SIOS 2 back to SIOS 1. So the role reversal of the mirror happens automatically. I don't have to manage that separately. And just to show you that this really happened, I'll go back here. We can look at this job for the S drive mirror, and you can see here in the DataKeeper interface that this information matches up because now SIOS 2 is the source, replicating back to SIOS 1. So very simple to set up. Again, if you've set up a cluster in the past, you already know 95% or more of what it takes to do this. We're just simply adding real-time block level volume replication to failover clustering to enable SANless or shared nothing configuration. So that's a quick demonstration. Now let me switch back to the slides here, and we'll continue with a case study. Okay, so let's bring this back up right now. And one of our customers, Spirent, they're a telecommunications, they provide telecommunications technologies, and they're a global organization. And one of their initiatives was to move all data center operations up to AWS. And in order to do that, they needed an affordable, easy to deploy solution to ensure that once their mission critical applications are up in the cloud, that it's also highly available. So they deployed a Windows Server failover cluster. They went with a 2-node configuration in this example. And instead of SQL, they're actually failing over a Siebel gateway server as well as a file share. That their application depends on. So they've got a 2-node failover cluster. Each node resides in a different availability zone for maximum availability. And they're leveraging DataKeeper, just as we saw, very similar to the demo I showed you here today, to replicate the storage between the different instances so that if and when they fail over between nodes, all the data is protected and replicated. So they get all the benefits of a traditional failover cluster that they were used to deploying and setting up, historically on-premise in physical servers. Now they have that same level of availability and uptime now that they've moved their workload up to AWS. So the next slide is an architecture. So this will look very familiar to the diagram that I showed before. So they have a 3AZ setup where they have their different cluster nodes in 2 different availability zones. The cluster's file share witness in a 3rd availability zone, and they've got 2 different clustered resources, one to fail over the Siebel gateway server, and a second clustered resource to fail over a file share. And if they do have an issue, it of course fails over the resources in the applications, in this case called a cluster role, over to the other node in the cluster, and DataKeeper replication automatically reverses here. So very, very cost-effective, very powerful way. They were able to reuse their existing skill sets because their administrators had been setting up failover clusters for years, didn't want to have to learn new failover, new clustering technology. So this made it a very easy to deploy, cost-effective solution for high availability for really any clusterable workload after you make the move up to the cloud here. So with that, we want to thank everyone for their attendance here today. We're going to open it up for Q&A.